Welcome to Real Chemistry. I'm Dr. Morris, and today on the show what we're going to do is talk about isotopes. Isotopes are just different versions of an element. So it turns out that elements out in the world come in different versions. So hydrogen has 3 different versions, for example, and that's what I've written down here below. This is similar to if you go to your Honda dealership and you buy a Civic, there's different versions of Civic. You can get the 2-door, the 4-door, the hatchback, and in the same way, hydrogen comes in different versions. And here, what we see is protium, deuterium, and tritium. You don't have to remember those names, that's not important. But what is important is those are all hydrogen. And the way they're all the same is the number of protons they have. So you'll notice 1 proton here, 1 yellow guy, that's positive, 1 proton here, 1 proton there. So the number of protons makes all of those the same element. It turns out that the number of protons, or the atomic number, defines what an element is. If you go onto the periodic table, you'll see a little 1 by hydrogen, and what that means is anytime you see an element with 1 proton, that is hydrogen. Now, what makes them different? The number of neutrons, these blue guys. And you'll notice that protium has 0 neutrons, deuterium has 1 neutron, and tritium has 2 neutrons. So we vary the number of neutrons and we get isotopes. Now, how do you write down the difference between these versions of hydrogen? Because we can't just call them all hydrogen. We have to have slightly different names for them so I can communicate which version I'm using. Some of these, by the way, will have radioactive properties that make them important, and some of them won't. And so I want to be able to tell the difference between the ones that are radioactive and the ones that aren't. So how do I do that? Well, isotope notation looks like this. Let's say we want to tell people that we have tritium. We write a 3, a 1, and an H. What do each of those mean? Well, the 3 tells me the mass number. That is the total number of things in the nucleus. Here you'll notice there's 1, 2, 3 things in the nucleus, 2 neutrons and 1 proton. That's where that 3 comes from. The number 1 down here is the atomic number, the number of protons, which I've already talked about. That tells us we have 1 proton. And lastly, we have the chemical symbol, H, for hydrogen, and that comes from the periodic table. So if I was expressing deuterium, instead, I would have 2, 1, H. And that 2 is there because deuterium has 2 things in its nucleus, a mass number of 2. It has 1 proton and 1 neutron. Or if I was expressing protium, it would look like this because it only has 1 thing in the nucleus, hence that top number is 1. Let's do some examples of going from isotope notation to the number of protons, neutrons, and electrons in an element. All right, here, it wants to know how many protons, electrons, and neutrons are in tritium. Well, we've already talked about that, but let's go through it step by step. So first of all, the number of protons is equal to the atomic number, which remember is this bottom guy here. This is sort of the symbol version of our isotope notation. For this reason, it's sometimes called AZE notation. And it tells us that this bottom guy, this Z, is the atomic number. Further, under step 1 here tells us that atomic number is equal to the number of protons. So the number of protons question is pretty easy. We know that the number of protons is equal to 1, as it is for hydrogen always. Then we want to know the number of electrons. And here, for a neutral element, that is an element that's uncharged, the number of protons and electrons are equal to each other. So that means the number of electrons is also equal to 1. Now, this is not always true because sometimes you have a charged species, an ion. And for ions, you'll have a different number of electrons and protons. So remember, this rule is just if your charged species, if your species is neutral. And lastly, it asks, how many neutrons are there? This is the only one that requires some math. The number of neutrons is equal to the mass number minus the atomic number. All right, so the mass number, remember, is this top guy, A here. And for us, the mass number in our symbol, you'll notice, is 3. Right up here, that's 3. So we need to do the mass number, 3, minus the atomic number, 1, and that's going to give us 2, which is the number of neutrons. Now, let's think about that conceptually. If you want to know the number of neutrons, the only thing that can be in the nucleus is protons and neutrons. So of course, if I take the total number of things in the nucleus and subtract the protons, I'm going to be left with the neutrons. Sort of like if you have a classroom with all guys or girls, right? If I know that there's 20 people in the classroom and 10 of them are girls, then I know that 10 of them are boys. And you can do the same thing here for neutrons and protons. Let's do another example. All right, this one says how many protons, electrons, and neutrons are in 29s16. That turns out to be sulfur. again, remember that the number of protons is just equal to the atomic number, which is this bottom number here. So the number of protons, well, that's going to be equal to 16. And the number of electrons is going to be the same, assuming our element is neutral. So if you ever see a charge on it, you can't assume this. So it's going to be also 16. That's because electrons are negative and protons are positive, and if there's equal numbers of them, they cancel out and give you no charge. Last one, number of neutrons. And remember that the number of neutrons is equal to the mass number, in this case 29, that is the top number, that's the total number of things in the nucleus, minus the bottom number, the number of protons. And when I do 29 minus 16, I'm going to get 13. So 29s16 has 16 protons, 16 electrons, and 13 neutrons. We could have different versions of sulfur, change the number of neutrons, but we couldn't change the number of protons. Always remember, the protons defines an element. All right, last example, we're going to go the other direction here. Let's say that we're told that an element has 7 electrons, 7 protons, and 7 neutrons, and we want to write out the isotope notation. So this is just going backwards. Well, the easiest place to start here is once again with the mass, or with the atomic number, which we know is 7. So we're told there's 7 protons. And that's going to give us the key to giving our chemical symbol. Because remember, our chemical symbol comes from the periodic table, and our periodic table is listed by atomic number. So all I have to go and do is find the number 7 above an element. And that tells me the chemical symbol I should use. And if I look at this section of the periodic table down here, I can see that nitrogen has the number 7 above it. Don't get it confused with the number below it. That is an average mass of all the isotopes. So don't use the number below N for any parts of these problems. It's not important for isotope notation. So that means we have nitrogen. And further, we know Z, the atomic number, is going to be 7. So now what we need to do is we need to find out, what should I write up here? Well, I need to write the mass number. And remember, the mass number is equal to the total number of things in the nucleus. So it's going to be equal to the number of neutrons plus the number of protons. Well, we're told here that there's 7 neutrons and 7 protons. And so that means my mass number is going to be equal to 7 plus 7, or 14. And so that's actually what I should write up here. So that's going the other direction. So you can see that isotope notation is not so hard to do once you know these rules. That top number, remember, is the mass number, the total number of things in the nucleus, including neutrons and protons. The bottom number is the atomic number, what defines an element, the number of protons. That's the same number you'll see above an element on the periodic table. And for a neutral element, the number of protons are going to be equal to the number of electrons. Thanks for watching this episode of Real Chemistry. If you have any questions, leave them below. As always, click that icon to subscribe. Thanks for watching.